Today we'll be quantifying atoms with moles, molar mass, and Avogadro's number. Avogadro's number, which is 6.022 times 10 to the power 23, just means the amount of atoms in 1 mole. We've got 10 exam-style questions here, and we'll be solving through each one. So let's start off with the first type of question. Determine the number of moles in 7.13 times 10 to the power 23 carbon atoms. So we have to first think, how many moles are in this many amount of carbon atoms? So to solve this, we'll divide the number of carbon atoms, which is 13 times 10 to the power 23, over Avogadro's number, which is 6.022 times 10 to the power 23. So we should get 1.18. And don't forget the units, which is moles. So we converted the amount of carbon atoms to moles. Now, find the number of water molecules in 3.5 moles of water. So we have to first think, how many atoms are in 3.5 moles of water? Or how many molecules are in 3.5 moles of water? So we have to just convert the amount of moles to the number of atoms or molecules of water. So we'll go 3.5 multiply by Avogadro's number, so 10 to the power 23. So it should give us 2.108 times 10 to the power 24. And you can solve these by putting them in your calculator. So yeah, on a scientific calculator. So, and don't forget the units, which is molecules of water. Alright, next question. Question type 3. Find the number of hydrogen atoms in 0.67 moles of methane. So methane is CH4. And we have to find the hydrogen atoms in this many moles of methane. So how many hydrogen atoms are in CH4? There's 4 hydrogen atoms. And we already know the mole of methane, which is 0.67. So all we do is 0.67 times 4, which will give us answer of 2.68. Now we're not done yet. This is the answer we got is in moles, but we need to get the answer in hydrogen atoms. So we have to find the number of hydrogen atoms. So we have to convert this into hydrogen atoms. So all we do is 2.68 times 6.022 times 10 to the power 23. Put this in your calculator and you should get an answer of 1.614 10 to the power 24. Don't forget the units, which is hydrogen atoms. So hydrogen atoms. So that's how many hydrogen atoms are in that many moles of methane. Now question type 4. Calculate the number of moles of oxygen atom in 4.55 times 10 to the power 24 molecules of sulfuric acid. So to find the number of moles of oxygen atoms, we can see that there is 4 oxygen atoms. So there's 4 oxygen atoms, right? First we have to just convert the molecules of sulfuric acid into moles. So to make this into moles, we have to so first we have to divide this by Avogadro's number, which is 6.022 times 10 to the power 23. So we should get around, okay, that's wrong, so this should be answer is 7.56 if you put this in your calculator. 7.56 moles of sulfuric acid. Now we've got the number of moles, and we can see there's 4 oxygen atoms. So all we do is 7.56 multiplied by 4 oxygen atoms, so just 4, and you should get an answer of 30.24 moles. There we go. So that's our answer. Now question type 5. Calculate the number of molecules of acetic acid, and if you have 2.3 moles of oxygen atom. So this is quite tricky actually, but whatever we did last question, you have to just think backwards. So we've got 2 oxygen atoms, so just write this is O2. I mean, there's 2 oxygen, so 1, 2. So to do this, we have the number of moles of oxygen atoms now, and we have to find the number of molecules of acetic acid. So what we'll do is 2.3 divided by the number of oxygen here. So there's 2 oxygen, so divide by 2. So we should get 1.15 moles. Now, this is how many moles are of CH3COOH. Now, to find the number of molecules of acetic acid, we have to convert this into number of molecules. So 1.15 times 6.022 times 10 to the power 23. And our answer should be 6.9 or 6.93, just significant figures, round up, 10 to the power 23 molecules of oxygen atoms. Of acetic acid. That's your answer. Now question type 6. Find the molar mass of CH3CH2OH. So now we're moving on to molar mass. So we haven't heard of this, right? So what we have to do, molar mass is just atomic mass. So we have to find the atomic mass of this. But how would we find the atomic mass of that? Well, we just have to find the atomic mass of the individual elements of this thing. So we've got CH3, CH2, OH, OH, okay. So what we do is we first find, what is C? The atomic mass of carbon is 12. Well, we round up. It's not exactly 12, but it's somewhat near that number. Now, atomic mass of hydrogen is 1. But since there's 3 hydrogens, we'll write 3. Then the atomic mass of carbon is also 12. And then hydrogen is 1, but since there's 2, we'll write 2. So 1 plus 1 is 2, right? And oxygen is 16. The atomic mass of oxygen 16. So we'll write 16. And hydrogen is just 1. So you can just find the atomic mass of each element on the periodic table. So that should be handy. So 12 plus 3 plus 12 plus 2 plus 16 plus 1. So the atomic mass of CH3CH2OH should be let's do some simple calculations. 15 plus 12 is 27, 29, 30, and then 46. I don't know if I did that right, but yeah. 46 is the molar mass of CH3CH2OH. Now find the molar mass of MgPO4 So what is the molar mass? So what is the atomic mass of Mg? So if you look at your periodic table, the molar mass, the atomic mass of Mg is 24.3, or let's just write 24. And then since there's 3 of them, we'll write times 3, like that. Plus, atomic mass of phosphorus is 31. So, and since there's, look at this bracket 2, this will be P, it'll go inside, and it'll be P2. And this will be O8. So what is so if it's 31, we have to multiply that by 2. And then we've got oxygen, which is, there's 8 of oxygen. So there's 8 oxygen, so atomic mass of oxygen is 16 times 8. And you should get your molar mass. Let me just put that into my calculator. So 24 times 3, then plus 31 times 2, plus 16 times 8. It's 262. That is a molar mass. So now we know Avogadro's number, molar mass, and all that. It's time to learn the real thing, which is this equation. So this is a ratio of which defines these three parts. So moles, number of moles, which is n. So n is number of moles, m is mass, and big M is molar mass. Just don't get confused between the small m and m. So m is molar mass, so it's and m is mass. So let's solve this. Calculate the number of nitrogen atoms in 45.7 grams of ammonium nitrate. So we have to find the number of nitrogen atoms. So what we do is we have to find the molar mass, the amount of moles of NH4NO3, which is ammonium nitrate. And we know that there is 45 grams of this, and we need to find the molar mass. So if you find the individual molar masses, which is nitrogen has an atomic mass of 14, hydrogen is 4, which is 1 times 4, which is 14 as well, and then oxygen is 16 times 3 is 48. And if we add this together, so plus 4 plus 14 plus 14, we should get 80. So we divide by 80. So we should then get the answer of 0.571 moles. Now we've got the moles of ammonium nitrate. How will we find the amount of the number of nitrogen atoms in this much moles of ammonium nitrate? So we just do what we did before. So since there is two nitrogens in ammonium nitrate, we'll just go 0.571 times 2, and we should get the answer of 1.142. So this is moles, but we need to find the amount of nitrogen atoms. So what we do is 1.142 times 6.022 times 10 to the power 23. So we should get 6.88 times 10 to the power 23 nitrogen atoms. And that is your answer. Now question type 2. Calculate the mass of 2.45 moles of ethane. So we can use our equation. So N is equal to M over M, big M. So we have to find the mass. So we have to separate out the mass. So mass is equal to N times M. Right? Now we have to find M. So we've got the number of moles. So N is 2.45, and then big M, which is molar mass. So what is the molar mass of C2H4? So carbon has a molar mass of 12. 12 times 2 is 24. Hydrogen has a molar mass of 1 times 4, which is 4. So our total molar mass is 28. So 28. So our mass is 2.45 times 28, which should give us 68.6. There we go. And don't forget your units, which is grams. Perfect. Now, last question. Find the number of ethanol molecules in 87.1 grams of ethanol. So let's find the molar mass of CH2 of ethanol. So ethanol has equation of CH3 CH2 OH, and molar mass of this, so let's find the molar mass. So N of this is equal to, so what is, so CH, so C is 12, H 3 times 1 is 3, C is 12, 2, 16, H is 1. So if we add that together, we should get molar mass of 46 grams per mole. Now we have to find N, which is so we've got the equation N is equal to M over big M. So we've got our mass, which is 87.1. Whoops, what happened there? 87.1. So 87.1 divided by big M, which is 46. We just got here. So 46. So that should give us an answer of 1.8893 moles. Now we have to find the number of ethanol molecules. So we have to convert this into molecules. So 1.893 times 6.022 times 10 to the power 23. So our answer should give us 1.14 times 10 to the power 24. That's your final answer, and don't forget your unit, which is molecules. And there we go. We've solved 10 exam style questions, and which should help you for your upcoming tests. And this is how to quantify atoms with moles. I hope you enjoyed the video. Please like and subscribe. Thanks for watching.